So radiation is useful for various industrial applications. First is combustion. Examples are in gas turbines, boilers, rocket engines, glass furnace, steel reheat furnace, various types of engines, that is combustion engines, IC engines, diesel engines. It is also useful for automotive underhood applications or in automotive applications of thermal modeling. It is useful in heating, ventilation and air conditioning applications, electronics, glass applications, furnace modeling. So how do we capture radiation in the CFD model? An equation similar to the energy equation is solved for radiation intensity in order to actually capture radiation phenomenon. Local absorption by fluid and at boundaries links the energy equation with this radiation equation, which is known as radiative transfer equation. Radiation intensity is directionally and spatially dependent, which means it varies with direction and space, so that is taken into account. Intensity along any direction can be reduced by local absorption and out scattering, which is scattering away from the direction. So this phenomenon of local absorption and scattering of radiations, which reduces the radiation intensity, is also fed into the radiative transfer equation. This is how the radiative transfer equation looks like. So we have in this equation, I is the radiative intensity or intensity of radiation. R is the position vector, which is this. R is the position vector. S bar is the direction vector, which is this S bar. Capital S bar is the scattering direction vector, which is given by this particular scattering. Delta is the path length, which is this particular delta. Absorption coefficient is alpha, which is given here. We have the scattering coefficient sigma s, which is given here. Sigma is the Stephen-Boltzmann's constant, which is also included in this equation. I is the radiation intensity, which depends on position and direction. T is the local temperature, which is used here. Phi is the phase function, which is this phi. And ohm is the solid angle, which is shown here. So this is the radiative heat transfer equation, which is solved in order to capture radiation phenomenon. This is basically a transport equation for radiation intensity. It considers the transport of radiation intensity, the reduction in radiation intensity because of scattering and absorption, and it considers the energy linking of with energy equation and temperature coming from the boundary as well.